Today we are going to discuss about deep learning. So in deep learning, first we have to understand neural network because deep learning is nothing but incorporating the neural network. That means to replicate our brain. So first we have to understand about the neural network concept, then how they are implementing that in the model. So that we are going to discuss. What we learn in this section is we learn about neuron and the activation function, how the neural networks work, how the neural networks learn, gradient descent, stochastic gradient descent, back propagation. So all those concepts we will quickly go through this. Then we go to the CNN, convolutional neural network, and then we are going to implement that. So this is the picture of the neuron. You can see here. This is the pic of neuron from brain to microscope. It is like this. So our brain is the most powerful learning mechanism on planet. So what they are thinking is, why can't we replicate our brain? Because it has the most powerful learning mechanism. So that's the idea behind the neural network concept. So this is the another picture of neurons. It will be like this. Okay, when you expand this. So there are three different things you have to learn in this. One is the center part of the neurons, that is called the neuron. Okay, and then this lengthy part is there. No, this is called axon, and the edges, small nerves, are called dendrites. So what they are saying is, these one neurons cannot do anything. Okay, so if you take only one means this cannot do anything. So we have multiples, millions of neurons are connected together to do some work. So that's how our brain works. It's not a single neuron in our brain that is working. The millions of neurons are act together to do a work. So that is how the neurons works in our brain. The same thing that we will see in this neural network also. So these dendrites act as a receiver. This axon acts as a transmitter to the neurons. So this is the center part of the neuron, and this axon acts as a transmitter, and this dendrites acts as a receiver. The next slide. So now we see the block diagram of the neurons. So this is the block diagram. Here you have the input values. So 1, 2, 3, any number of features. There you in machine learning we call features, right? Independent variables. We have multiple independent variables. Like that, you will have n number of features. Okay, and then all these are passed into the neuron, that is the center part, and we have the axon, that is the output signal. Okay, so this is the representation of neurons. Okay, and this connecting path is called synapse. In our case, what you are going to do is we take this yellow color. We remember this coding. This yellow color as input layer. This green is a neuron, and the output is red. So just keep that in mind. So this is the standardized color coding for representing the neurons. Okay. So the output may be continuous price. It may be a in machine learning we call that as regression, a continuous numerical value, or it is a binary yes or no, or it is a category. Not we are not only see binary means either yes or no, 0 or 1. But in many cases, in some applications, you will have categorical also. That means more than two outputs, either yes or no. There may be another set of output is also possible. We call that as categorical or multiple output. Okay, all these things are possible. The output layer. The output layer is not a single output. You will have multiple output also. Similarly, the input is also multiple. So another important, so the categorical means more than two, right? So when you have two means yes or no, that means you have binary output. More than two means you have n number of output is also possible for some applications. Okay. For example, when you are determining the um, any diseases, you will have different types of levels: level one, level two, level three, level four. So any one category will be the output, isn't it? So it's not that only two, either you have disease or not. Sometimes we have to categorize the level of the diseases also. So that's why in some applications you will have multiple values in the output. We call that as category. And another thing that we have to learn is this one. So the neurons as the synapse, this is the synapse, this line, the input layer and the neurons are connected with synapse, right? So you have weightage for every link or synapse. So for example, the input from the input layer to the neuron is as a weight W1. Similarly, for the input layer 2, for the input 2 to move to the neuron as a weight W2. Like that, you have a weightage in the neural network. Okay, so that determines the learning capacity of the neuron. So if the weightage is high, more importance has been given to that input. If the weightage is less, less importance has been given to that particular input. So what will happen inside the neuron? So the input values are there, and we will have some weightage because some has more weightage, some has less weightage. Some features may have more weightage we have to give. So like that. And then inside the neuron, what is the function? It is not that function is uh, nothing but summation of weightage, all the weightage and the all the inputs. So that is the function that is taking place inside this neuron. This is summation of weightage and input value. Okay, all the weightage and all the input values, and then that will be sent to the output. So with that, we have one more function that is called activation function. So first, you have the summation, that is the general thing, and then you have another thing that is called activation function. So what is activation function? We will discuss later, because that is the function that helps to transmit the information in the neuron to the output value. So there are so that is the first. After application of the activation function, the information from the neuron has been moved to the output value. So there are a different activation function. So one is threshold function. So threshold function means either 0 or 1. Okay, so the output will be either 0 or 1, that has been applied to the weightage function. So why this activation functions? What this activation function represents is in our neuron, in our brain, you have a uh, you have a pulse. Okay, like electrical signal is there in our brain. So that is represented as activation functions in the neural network. In our natural brain, we have electric pulses in our brain. So that helps to transfer the signals from one from the input to the output. So the same thing they replicate here as activation function. Okay. So there are different types of activation function based on the applications as well as the layer. So if the application is either 0 or 1, in that case, then we can use a threshold function. And if the application is a probability based algorithm, then we have to use sigmoid. Okay. So sigmoid is nothing but it starts from 0 and ends with 1, but it has some probability function inside it. And another one is the most popular one is rectifier or reloop. So here we have it also starts from 0 and maximum is x. So this is the maximum. It's like a RAM. Okay. So that is the most popular one. That mostly they will use this reloop function at the output. And then another one is hyperbolic tangent. If you want to cover the values from -1 to +1, then we can go for this activation function. So it's like a pulse, okay, that we are giving for operating the neural net. So that is all about the step 1, step 2 and step 3. Assuming that you have a dependent variable. So this dependent variable is binary 0 or 1. Dependent variable means what? Output. Independent variable means this one. Okay. Y is the output. You can see here when your dependent variable, that is your binary output, is either 0 or 1. In those cases, in machine learning, like uh, classifying the uh, classifying the diseases, like that we have seen, no? So for that, what are the activation function they will use at the output layer is either they will use threshold activation function or sigmoid activation function if you are classifying the output, the binary output if you are classifying. So like that, you have different formation. So that is a quick introduction of artificial neural network. So only one more point is left. The first thing is we have the input layer, multiple input layer. We call that as dependent variable or independent variable. And the next thing is your hidden layer. Okay. And then this is the neurons, right? And then the next is the output layer. So you have multiple neurons. It's not that single neurons. We have thousands of neurons also possible. We can make a neural network with that. If you want more if you have more data, if you want to process more, then you can increase the neuron based on that. Another thing is all the neurons are connected with each other. The input layer and the neurons are connected with each other, and all the new hidden layer as well as the outputs are connected. So why this called hidden layer is we will give the input and we will see the output. Between that you will have hidden layer. So you will not have a single hidden layer. You will have multiple hidden layer. We can increase that also. Either we can have a fully connected network or we can drop out some of the links also. That is also so just we are passing that information fully connected because all the X1 has been connected. All the input value connected to all the neurons. That is fully connected. And then we will we'll apply the activation function. Once you apply the activation function, all this information will be passed into this output. So before that, remember you will have a weightage here that gives the learning that determines the learning of the input value from the by the neurons. That's all. And we have in the output we have two layers. So that is how this artificial neural network will work. So I'm going to give one exercise to you. So why I'm going to give exercise to means because we are going to implement CNN. So this is comparatively very simpler. Once you understand the CNN, then you can do a ANN, that is artificial neural networks. So we have a lot of data set in the machine learning. We have discussed various algorithms. One of the algorithms that we discussed is house pricing. In house pricings, so you can see you have area, bedrooms, distance to city, and age. So this is one of the combination. Okay. So these are the independent. I'm just going to give an overview of this, and I will send the code also at the end of the session. You just work on it. Okay. And this is x1, x2, x3, and x4. Okay. These are the independent variable, and we are going to have some weightage, or we can that weightage will be determined by the artificial neural networks. We cannot able to give the weightage value. Initially, we will fix some things and then it will be updated based on the gradient descent. So that I will come to later. But these are the weightages and then output layer is y, and we're going to have a output price, the combination of these things to determine the price of the house. So we have the input layer and hidden layer. All these are connected. Okay. And then finally you'll have the output. So this is the thing. I will send the code to you. Just go through it. And so that's all. Okay. And one more important thing here is, so this is the thing we want to know. So what we are going is we are initially set some weightage and then we are calculating the, and this will be the summation of the weightage and the input value, and we have the output. but this output is a predicted output. Similarly, in the machine learning algorithm also, we have a difference between the predicted value as well as actual value. We call that as error, right? So here also the same thing. The neural network performs some function and then gives the predicted output value, but that is not exactly same to the actual value. So what we have to do is we have to again do some correction. So the difference between the actual value and the output value is called cost function that we have discussed in the machine learning algorithm. Okay, that will be back propagated. So that difference will be back propagated and it is given to the, again it is passing into the neuron and it is adjusting the weight. So based on this error, the weighted will be updated. Okay. After that, again the weight will be the after that again the input signals will be sent and then that is called second iteration. After waiting, we have another time we can do that, the same process, and then it calculates the output on the actual, and it calculates the difference, and it is back propagating. So this will be automatically done by this neural network to reduce the error. Okay, so that is one of the thing that we have to understand. Okay, and one more thing is we can send the input signal by one or we can send by batches. Okay. For example, we can send eight data at a time or 32 data at a time. So like that, we can send batch by batch also we can send, or we can send one by one also we can send. So that will be determined by the batch size. And again, this gradient descent that we discussed on the linear regression, why this gradient descent will be used is to reduce the error, to reduce the cost function. We are using gradient descent technique. So initially it starts here or randomly anywhere in this place. So this point is the highest error. Okay, and this is also highest. So step by step, after every iteration, the error is reduced. Step by step, the error is reduced, and finally it reaches the bottom. So bottom is the minimum error that we can have in the data set. So that is the optimization of the optimization error. Okay, so to reduce the cost function, they are using this concept gradient descent. So that's all about this quick introduction about ANN. Okay, so we will have some idea about neural network now, and the things that we have to remember is input layer, weightage function, and then hidden layers, and then you have the output layer. Also, we have to remember the activation function. So these are the things, parameters that we are going to use in this neural network. And then back propagation to reduce the error. So we have two things in the neural networks that will be used in most of the applications. One is convolutional neural network. Another one is recurrent neural network. Okay. So I will tell you what is the difference between that when we are discussing a recurrent neural network. First, we will discuss about convolutional neural network. Convolutional neural network is mainly used for image processing. Okay, so that is the thing. So why ANN? ANN means the artificial neural network, natural, ordinary, normal artificial neural network. Why we cannot process the image means the image is of huge size. So we have a 4K images are there, 8K images are there. So that means we have 8,000 inputs are there. So we need 8,000 inputs to process one image. So that will be very difficult to process by the ANN. Okay, so that's why they are using ANN for small data sets, and then for classification of images, convolutional neural network performs better because of that algorithm. Okay, let's discuss about this, and you can see in this picture what we can understand from this picture. When you see this picture, what you can understand. So one point of view is it's a side angle, right? and the another point of view is looking us forward. So in both the cases, we can uh, both angles exactly right. So it looks right or it looks front also. What about this one? What about this one? You can have some here. You can see this one. I'm just giving some clue. So here you can see another face also, right? The face or an young lady looking backwards. So this is the hair and this is the iPod and then ears. Okay. So can you can you see this way? So this is one old lady looking downward and young lady, another lady looking back. Okay. So when you see this upper portion, this is your hair and then this is eyes, this is mouth and then ears. Can anyone? Okay. So I'll go a little bit easier. This one. What about this one? So that is also. So we have. So what we have to identify, what we are identifying means our eyes captures only the features. So what we are seeing here is we are seeing only the features, the shapes and the variations in the images. So that only we are capturing. Based on that only our computer vision is working. Our eyes are working. Okay. So we have to remember that. So here also we are seeing only the shapes and the textures and the colors, different variations in the image. So based on that, we are determining what kind of image is that. So in the similar way, the huge picture, if you take 8K or 4K or a big picture, if you take the size, it has lots of information, but we are not seeing all the information. Okay, what everything is that every color we are not seeing. We are seeing only the features in that image, and then based on that, we are reading the image. The same concept they are using in the CNN. Okay, what in CNN they are doing is they are seeing only the features. Based on these features, they are determining what kind of image is that. Okay, so that is the thing. Here also you have some examples for that, and this is the cheetah that we are sending into the applying CNN over there, and then it determines correctly that cheetah. This is the determination, and then it also says leopard little bit and snow leopard and Egyptian. So when you see this image, the bullet train is coming. Okay, it again determines correctly as bullet train. How it is determining that by seeing the features alone. And sometimes this prediction is also another other predictions are passenger car. It may look like a passenger because some of the features resemble to passengers cars or subway train or electric locomotive. So these are some other options, and we have here hand glass. But the based on the features, the CNN determines this as scissors because it also resembles like scissors and hand glass. But this is hand glass is the correct one, and it also looks like flying pan or stethoscope. So this in this way we can able to determine the images. Okay, what kind of images is that, and also we can based on that we can do some classification also. Okay, now we will see how the CNN works. We have the input image we are going to send as an input, and CNN is the convolutional neural network, and we have the output that is class. Okay, what type of image is that we will identify. So the applications, many applications are there in the based on this image classification, image analysis. We can do all those things using CNN. Okay. Here I will illustrate this works of CNN with a simple example. And this is one emoji, so happy face, and this is the sad face. And we are applying that to the CNN. CNN is the model or algorithm neural network that learns the features and it says this is happy and this one is okay emotion determination. Okay, and how this will work is how the CNN works is, so this black and white image. So first we will understand something about this image. And two types of images. One is black and white image. Another one is color image. And the images are in the basic unit of images are pixels. I think we know that pixels. The pixels are of different values. Okay, the values of this pixel is from 0 to 255. So that means 256. Okay, and it is a two-dimensional one, and then we are have this. Okay, and for color image, it is a three-dimensional array. What that means is we have RGB plane. RGB, red, green, and blue. So we have three planes. Here we have only one plane, and each pixel has 256, 0 to 255 value. Here you have three planes, and each plane has the values 0 to 255. Any value it may be. If it is all 0, we call this black. If it is all 256, then it is white. Okay. Now we'll look at this image. So we take this as a black and white image, and then these images, this whole image has been in the form of we are representing that in this form. Okay, it has either the value of highest value or 0. Okay, so or in the form of black and white. We keep that as in form of black and white. This represents the features. So here in this emoji, you have two features, that is eyes and nose, and then lips. And then we are converting that into values, because the neural network will not read the colors. It will read only the values, numbers. So how we are converting that is, it is a simple example. This is 0. This value is 0. We call that is pixel, right? This is 0. So for white, we keep as 0. For black, we keep as 1. That is 255. Black is represented, I think I have set it in another way. So for white, it is 0. For black, it is 1. So that means 255. Okay. And then we will have the zeros here. In the second row, we have 0. And then here it is 1. In 1 0, it's not matching this one. Okay. So this is not exactly same. Okay. But you just, this idea is same. But so this is 1. This high is represented here as 1. And this high is represented here as 1. And this nose is here represented as 1. And this lips here is represented as 1. So these are the features. And all other things are zeros. So what is the size of this image is 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Here also 1, 2, 3, 4. So it is a 7 cross 7 image. Okay. How the CNN will work? So we send this to the CNN algorithm. So first step here is convolution. Second one is max pooling. Third one is flattening. And fourth one is full connection. Okay, we'll see the first step. How the first step will work. First step is nothing but convolution. Convolution is given by this equations. If you are in electronics and communications, we will represent the signals and systems in the convolution. Okay, so it is nothing but the integration of two functions. Okay, convolution is nothing but the integration of two functions. Let's see what is happening here. So this is one thing, that is image. We call that a 7 cross 7 image. We know this is the features of the image. And then we have another thing that is called feature detector. Usually have a multiple feature detector. Okay, so single feature detector will detect one feature, any one feature in the image. Okay, if we have multiple feature detector, you will have multiple features detected from the image. So that is the use of feature detector. The name itself is a feature detector. It detects the features from the image. Usually it is not a, you will not have a single feature detector, you will have multiple feature detector. The size of this feature detector is 3 cross 3. We call that as filter or kernel. So that are the other names for this feature detector. Okay. So what we are doing is we will apply this feature detector into this image one by one. So first we will apply this feature detector in this area, and then we'll calculate, we will just do the product of these two signals, and then we will have the output here. Let's look at here. So this is the second after applying in this first area, then we are shifting that to this place. In that we are multiplying. How we are multiplying here bit, we call that as element wise multiplication. Here 0 and here also 0, that means 0, and here 0 and here also 0, that means 0, and here 1, here 0, that is again 0, and here 1 and here 1, we have 1, and here also 0 and here also 0, here also 0, and here is 1, but there it is 0, here is 1, then there is 0. So when you do that bitwise element wise multiplication here, you have only 1. Okay, in this place only you have 1, and here also 1. So this feature has been mapped into this future map. Okay, and then we will again, then in the next step we will again shift one point. When you shift to one point, what will happen is again it will multiply these two, the image as well as the feature data. Here all zeros, definitely the output will also be 0. And again it shifted one step, and then it calculates. Here only 1, but corresponding to this place you have 0, so definitely that is also 0. And then when you move into this point, you'll have only 1, but that place will be 0 again, 0. So like that, we will shift the one by one, and then we'll have the values. So when you come to this point, I want to tell you, here you can see 0 plus place, second place also 0, but here you have 1, and here 0, again 0. In the second row, 1 is there, 1 is there, so 1 and 0, 0. And in this point, 0, here also 0, and this point is 1, and we have 1 plus 1, 2. Okay. So that's how the future map is formed. Okay, one by one. So here also you have four features are mapped here, so we get 4 here. So like that. Okay. So what we have done is we have applied the future detector, and then we have taken all the features alone from this input image to the future map. The size of this one is 7 cross 7, but the size of the future map is 1, 2, 3, 4, 5, 5 cross 5. So we are reducing the size of the images also in other hand, but we are not losing any features here. So we have considered all the features, but we are not, in the same way, we have reduced the size of the image also a little bit. So this is for one feature detector. Like that, we will apply many feature detector in the convolutional layer, and we will have a, after applying many feature detector, you will have many feature maps. Okay, that is called convolutional layer. So initially the image is very huge, and then we will apply feature detector, multiple feature detectors into the image, and we'll have a multiple feature maps. We call that as convolutional layer. So this is step 1. Okay. Now after that we'll apply the activation into this to increase the non-linearity in our CNN. So because so we are not only dealing with the linear inputs, we also want to uh, see the non-linear, because the variations in the images are not linear, it is also non-linear. So we have to apply the rectifier function in this. So this is the image. After applying the convolution layer, you will have the images like this, but it takes only the features. Other details are removed. So this is the sky. So you will not have anything here, but the variations in the images has been taken. So that's the example. The next step is max pooling. The next step is max pooling. When you see this image, so this is also cheetah, and this is also cheetah, and this is also cheetah. But you can see here it is in the front force. It is somewhat tilted, and this is somewhat strengthened. Okay, but the neural network needs to identify all those things and determine this as cheetah, right? So, and then you can see here all these are cheetah again, but it is in different forms. Here it is the head only looks prominent, other things are not there. Here also we have a body and then it's of different form. This is also in different form. So this is of different form. This is closed one. This is long short. So like that, all this are cheetah image, but these images are they're different in many ways. So we have to consider that also when you are seeing the features of the cheetah. We have to consider all those things. So that will be identified by this max pooling function. Okay, how the max pooling will work? How the max pooling will work? So let's look at this. This is your feature map. So we are moving from the step one to step two. In this feature mesh, we are going to apply some max pooling, and the output of that one is pooled feature map. How the maximum pooling will take place is similarly we will apply one by one thing, but here we have a different types of pooling. One is max pooling, another one is min pooling or average. Okay, call that as mean pooling like that. So I will tell you what is that. So similarly, you will have 2 cross 2 uh, function here. So initially it will see this uh, first thing in the feature map, and it sees what is the value. Since we are applying the max pooling in this 2 cross 2 array, what is the maximum value? So here 0, here 1, here 0, here 1. So maximum value here is 1. If you are having min pooling means you will have 0. Okay. If you are having average pooling means you have to do the average of this. Okay. Similarly, we move to the next point, 2 cross 2 matrix. Here also it says 1 is the maximum value. Again it goes. Okay, here you don't have any values. So it will consider these two values and says it is 0. Okay. The next point is, it says here 1014. Here the maximum value is 4. So the 4 will be updated in this map. And here 2 is updated, 1 is updated, 0, 2, 1. So this is how this feature mapper has been formed. Okay. So now you can see the size. So this is 5 cross 5, but here it is 3 cross 3. So we have the feature, but the size is reduced. Okay, but we are preserving the feature. So that is the advantage of pooling. Okay, and similarly, after the convolution layer, if you apply the pooling, you will have the pooling layer. Okay, smaller size. So this is a big size. After applying the convolutional, we have the feature. After applying the pooling, again you have the feature, but the size is reduced further. Next, we go for flattening. The third step is flattening. After this feature map, what we are doing is we are converting this 3 cross 3 into a column array. So 1, 0, 0, 4, 2, 1, 0, 2, 1. So that is called flattening. Converts the pooled map into column. After that, we are sending that to the input layer of the neural network. Okay. So here only we are in the neural network. So we already discussed about the neural network, how it works. So here we are going to use the neural networks. That's why the name called convolutional neural network. So first we apply the convolution, and then we are applying the pooling and then flattening. The output of the flattening will be sent to the neural network. Okay. So all these are features. Actually, we call that as features, but how the algorithm sees is the variations in the image. different variations, where the variations are coming. Okay, based on that variations, it is determining what kind of image is that. Okay, so for eyes, there is some features. Okay, and similarly uh, for uh, for nose, you have some variation. So it captures that variations. So we call that as eyes, nose, and all. But usually, what the algorithm sees is it sees only the difference in the images, and then based on that, uh, it is learning the images. So what kind of images that is learning. So this feature mapping is of different values. So you can see now when you go back into the future here in our example. So this is nothing but 001, 100, 1011. Okay. So we have some features based on this. Okay. Uh, when you have here you can see 4. Okay. So this is some feature, right? Okay. This is lips and this is nose. So this feature is exactly mapped with this feature detector. Then it says 4. Okay. Maximum value in the feature map. So it sees the values of this one as well as this one. And then based on that, it captures that feature. So it sees only the values. So that's what it is impossible for us to imagine that. Okay. But what is happening is it captures this information using this feature detector and it is updated here. So when you do the reverse process of this, okay, you will reach this point. Okay. So based on this information, uh, the neural network performs some all the things and then it is classifying the images. Okay. So we'll see that. Okay. But this is the answer for your question is it sees the features here and it detects that feature using the detector and it is, so some feature detectors are 0. So the same feature detector here doesn't have anything to detect because this feature does not match with this feature detector. So that's why we need multiple feature detector. Here also one feature is there, but this feature is not detecting that. It says it is 0. So when you have more feature detector like this, hundreds of feature detectors, then you can have all the features here. It is mapped. Okay. So it's
Yeah,
not
yeah.
that single feature detector, you will have multiple. That means it captures every information in the image and it is by the on the other end it reduces the size because for artificial neural networks we cannot have uh, 8,000 inputs like that. So that means you need a huge neural network to process that image. By using this, we can reduce to the minimum level. Okay, and then we can apply the print to artificial neural. So your artificial neural network is going to determine what kind of feature is that, what kind of information. Before that, we are resizing the image into small size, but we are preserving the information. That's how we have to understand this. After flattening, we are moving into the neural network part. So this information alone is sending into the neural network by one. The first, second, third, like that it is passing. And this is your input layer, and you have the fully connected layer, hidden layer. So this is the hidden layer, and you have the output value 1 and 2. So what is our aim is we are going to classify the images. We are going to have a set of images. That set of images has two categories. One is cat, another one is dog, and it is going to classify this. So this is one um, application classification of images. Okay, that's the thing. And let's see how this. We imagine that we have fully connected neural network. That means every input layer has been connected to the hidden layer, and every hidden layer has been connected to the another hidden layer, and every hidden layer has been connected to the output. So that is the. If you want to take out some of the connections, also we can do that. But in this case, we are taking everything as fully connected. This is forward propagation, and this one is backward propagation to reduces the error in the prediction using gradient descent. How it is going to reduce is by adjusting the weightage, the link, the synapse. Okay, so now we come to the point. So actually, what we have done is already we have applied the convolutional max pooling and then flattening. After flattening only, we are applying that into the neural network. Okay, when you apply this into the neural network gets trained. It has some values over here. Am I right? So you have some value here, and we have the weightage. The summation of all those things, you have some values here. Similarly, when you're passing that to this hidden layer, you have some values. So these values used to determine what kind of image is that. When you are, this is how the neural network learns. When you have the first image, let's assume it's a dog image. We are sending into the neural network, and your neural network gets trained. So dog has some features. Am I right or not? Dog has some features, long ears, puffy ears. Okay, so like that, it has some features. So that detector, that value has been updated here. So here you get zero point 0.9, and you have 1, 0 0.2, 0 0.1, 0 0.2, like that. The values will be updated based on these values. Okay, and these values, all these are connected to the dog. Okay, when the neural network sees this as 1, this as 9, and this as 1. Okay, so initially now the neural network learns, doesn't know anything, just getting the number. Okay, and it has some values over here. So some of these are very low value. Okay, and then it is predicting either dog or cat. And we are when you are training the model, we know what is dog. This is dog image or this is cat image. We know the training, and it says dog. So whenever dog comes, these these neurons as well as these neurons and these neurons have the highest value. Okay, so that means it gives more weightage to this point. Okay, and whenever more weightage to this points because this may be some future, maybe a years. Okay, the dog has some long ears, maybe the eyebrows, maybe the mouth. We don't know, but these whenever dog comes, these three neurons have high values. So the neural network understands this, and it gives more weightage here generally. And when the cat comes, so it based on that it determines when these three neurons are high, we have to keep that as dog. And then for cat, when training, we have lots of cat images will be there. And again, for cat images, these neurons will be because this may be the for cat you have triangle ears, the eyes may be different and mouth may be different. Okay, so we have some features, right? So obviously, when you're training the model, this will be the output. Okay, based on this point of view, the cat determines that when these neurons are, the neuron network understands that when these neurons are high, then it must be a cat. Okay, so for cat, we will have high weightage to these links. For dog, we will have a high weightage to this. So that's how it will be, the weight will be adjusted automatically. Okay, so this is how the working of neural network inside. So we have done the training. From the training, we understood that the neural network understand that for cat, these neurons must be high. For dog, these neurons will be. Then you will have some values for all the images. You have some values for the dog, and you have some values for the cat. Which one is higher? Based on that, it will determine this as dog or cat. Okay. So this is the dog image now we are sending, and you can see definitely this when during training we came to know that these three are representing the features of dog. Okay, and these three are representing the features of cat. So the obviously the value will be 0.95 of this one. for dog and 0.05 because we have low values here, but we have high values here. When you compare these two, we can predict this as dog. For cat, the values will be different. For cat, we have 0.79 and here 0.29, and based on this, we can predict this as a cat. So this is how the neural network works. Okay, now you can able to see all those things. Okay. So first input image, convolutional, only the features we are taking. Again, only the features we are taking, and then we are applying that to the neural network. These features, when into the neural network learns what are the features, okay, for the dog, and what are the features for the cat. Because we know which one is dog, which one is cat. The neural network also know during the training. Okay, and then based on that, the weightage has been adjusted, and the model is trained. Once the model is trained, when you apply a new image, it will, based on the values of this node and this node, it will compare these two values and says whether it is a dog or cat. So that's how the CNN works. In that, you have CPU, GPU, like that. So we have to select GPU. So this GPU has some limitations. The OLAP. Okay, so what this GPU is, it will to run this deep learning network, we need GPU. We cannot run using a common uh, thing. Okay, so we have to select this one, and then because we need a high processing unit, graphics card. If it is there means we can use. But since we are using Colab, we need a GPU. So that's why we go to runtime, change runtime to GPU. You know, use this only for deep learning. Don't use this for machine learning. By default, it is connected to normal RAM and normal speed. And then if you want deep learning means you have to go for this. And then connect. Okay. So here it's a GPU. So what it says is Python 3 Google Compute Engine backend GPU. Okay. Next, we have to see the library functions. TensorFlow. TensorFlow is the library that we need to use for neural network or deep learning. When you are using deep learning means the one library that is very much needed is TensorFlow. In machine learning, scikit-learn is the most commonly used, but in neural network, TensorFlow. Okay. What is tensor? Tensor means numbers, group of numbers. So what we have happened is we have converted all the images into numbers and we are sending that to the neural network. The neural network reads the tensors and it produces again the numbers. So we call that as tensors, the group of numbers. I call that as tensors. And here TensorFlow.keras models input sequential. Sequential means forward propagation. So we have the input layer, hidden layer, output layer. And we are using convolutional neural network, and then max pooling we are using, and then flatten we are using, and then dense. Dense means all the neurons has been connected to all the neurons in the next layer. Fully connected neural network. And again, pre-processing. Here also we have to do some pre-processing. The function for that is image data generator. We call that as data augmentation. I will explain you what is that in the coding part. And then matplotlib, we are familiar with that. Okay, and then zip file. So why the zip file means? So some of the data are very huge, so we cannot have in the form of folder. So we may have that in the zip file. Okay? So maybe have different categories inside that. So for that we can upload the zip file in the Colab, and then we can able to unzip that. And NumPy is for array, and then CV2. CV2 is for computer vision, and Google Colab patches import CV2. So this may be not used here, but what this one is to show the image. Okay, we need Google Colab patches. If you are using any other ID like PyCharm or spider. In that we no need this CV2 underscore IM show. We can, if you use IM show, it will show the image. So IM show is image show. But in Google Colab, we have to use CV2 IM show. So that's why I'm including the Google Colab patches. So just run this. So, okay. Now I have sent one link on the WhatsApp group. So copy that link and paste it here. So this is the link I will send to you. So what this means, this is the link in the Dropbox. So I have uploaded the cat dog folder, zip folder on the Dropbox. That link I will send you. So we can access the folder from the Dropbox also. Not only that, we can access the uh, folder from the drive. So if you have the folder in your drive, then you can use this code for that. So loading the images from the drive, you can use this. The zip file is in your drive, you can use this code to download that on the notebook. If it is in the Dropbox, you can use this line of code to get that in your notebook. Okay. So wget is the function and the link. So when you click that, what will happen is it will take the file from that link. Okay. And when you see here, you can have that file. So this is the file I have uploaded. You got that file on your notebook now. So see the size of this file is 78.5 MB. The next thing is we have to unzip. How we are going to unzip means unzip, okay, minus Q. The link is here. So what this link is, this is the link from this point. So copy the path from this location and then paste over here. So this is we get, and then unzip. For unzip, you just copy and paste. Like we paste the data set. Just run this. Now it is unzipping. And when you see the folder here, you can see it is unzipped completely. Okay. This data is downloaded from the Dropbox and is stored in a notebook. So when you unzip it, this is the folder that I have uploaded. So inside this, when you go inside, you have the test set as well as training set. In the test set, you have cat and dog. In the training set also, you have cat and dog. So you have cat. So you have around 3,500 cat images. The data set. And you have dog. Dog is also around 3,500. In the training set, so in the so it is the test set of the training set. In the training set, let's see how much. So total image is 3,500. Okay, it's going like that. So it is around 1,800 still there. It's a huge data set. After training every image, the neural network knows what type of feature and which neural network we have to give weightage. Now, so I told already, when you have the file on your drive, you can use this. So just copy the link, that's all. Now we are using the keras function, tensorflow.keras, pre-processing image, load image. So let's check any image. Okay, in the training set first, I take a dog, take 100 one, copy path and paste the copy here, the path here. So any path you can take. So just we have to check whether the data is connected with your Colab. Just run it. So the load image function loads the image in that location. So you can see this is a dog image. Similarly, if you want to take some image from the cat, you can take this 1,002 image, paste it over here and check. So this is a cat image. So I take any random image, my data set is correct, and then train and test. The next step is train and okay. Now you can see image data generated. So what this rescale is doing is it will do some scaling. Okay, so the image is of different sizes. It's not that the image is only two. Uh, it has some particular values. Okay, it may be from 0 to 255. Okay, so if you take 255 value, then we have to the processing of that image it becomes difficult. So we are going to scale that values from 255 to 0 or 1 or some range. We have to do that. So that is this scaling function will. So it is not that we are not changing the values, we are scaling the values like the feature scaling that we done in the machine learning. We will scale these values because 255 is a huge value. It takes a lot of time to process. Instead of that, we can normalize the values in the image. So that means rescaling. Okay. And then rotation range. Rotation range is equal to some means what this rotation range is. The image may be rotated in different ways, right? Okay, so the image feature, the image may be in the front angle or side angle or any angle. So 360 degree rotation is there. So it will, we will have some rotation rate so that the image will be rotated and the feature will be detected. Okay. And then horizontal flip. So this is also one type of rotation. So some of the image may be upside down. So we can do some horizontal flip also. And then zoom range. We can fix some zooming into that. So when you want to detect some features, we can fix some zooming also. And that range will be 0. So these are the values that we can fix. Okay, we can see what kind of value in that. When you apply, go to the TensorFlow image data generator in the Google, you will get. Okay, image data generator, you will have the examples for that, and from that you can learn. So what to do, what not to do. So we have lots of things like that. These are the zoom range, shear range. Okay, so we have a lot of feature. You can vary a lot of features in the image. Rotation, epsilon, whitening. Okay, so lots of things. So these three we are using for, and then we are storing that in the training generator, and we are applying that in the directory. So what is the directory means? So I'm going to apply that for the training. The training set is the directory name. So copy that path. So we have the test directory. So inside the folder you have test set as well as training set. We call the test directory because inside you have cat and dog. I'm just copying that and I'm pasting here. Okay. And target size. So what this target size is? Image is of different size. So we resize that image to 64, 64. All the images has been resized to 64, 64. Or we can use some other values also. And the batch size are already typed. Instead of um, sending one by one, after flattening, instead of sending one by one, we can send as a batch of 8. Okay, first 8 batch, and then the output has been calculated, the error feedback has been sent, and then the weight has been adjusted. And the next 8 batch, the output after 8 flattened input only, the output will be determined. So we can send the images by 8 batches. If you can send by one also. If you send one by one, each time the output will be predicted output and the actual output will be compared, and then the error will be updated. So instead of that, we can send by batches. That is another thing that I told you when we discussed the artificial neural network. And the mode is categorical. Class mode is categorical and shuffle. We can shuffle the images also. Okay. So the categorical means what are the categorical inside the images is we have 4,000 images that is belonging to 2 classes. What are the 2 classes is we know that it is cat and dog. Okay, that will be represented as zeros and ones. For cat we name as zeros. For dog we have name as one because The artificial neural network does not understand cat and dog. We have to convert. This is for label encoding. So we have to convert that to zeros. And once if we have more categories, we have to do label encoding there. After that, for test images, we are again doing the rescaling of the pixel value, but we are not applying this rotation, horizontal flip, zoom in. Well, the reason is it is a test data. We have to give a good test. Okay, to apply for the test data. For training, we can apply all those zoom in, zoom out, and then we can take the different features. But for testing, no need to do that. So whatever the size and whatever the features, based on that we can able to determine. So how many images for the test is 1,000 images. Again, we have two classes for that. And now we come to the building and training of neural network. This is very interesting form. So we call that as sequential because it is feed forward the input layer to the output layer, and we are adding the convolutional network into the output. So before the neural network, we need what? Convolutional neural network. So what is the size of that one is 32. So how many filters or kernels or feature detectors we are using here is 32. So 32 is the number of kernels that the convolutional layer will learn. Convolution filters or kernels or feature detectors. The size is 30. No, the number is 32. So number 32 kernels. The size of that one is 3 cross 3. Okay. We can fix. Now we can go to and see. So some ask what is the size we have to fix or no. Okay, we can fix the kernel size as well as number of kernels also we can fix. And then input shape. Input shape we fix as 64, 64, that is the resized image. And then 3 means RGB, and the activation function is reloop. After that, the first step is max pooling. The max pooling, the pool size we are determining here, that is 2 cross 2. And again, not this is the first convolutional layer. You can add multiple convolutional layer also. Okay. So again, you can see another convolution layer. So here 2 cross 2. Again, what we are doing is we are applying the convolutional layer. Again 32 convolution layer and then 33, and then we are applying again the max. So that is also possible. If not, only one also good. Okay. So I am giving all the options here. And then I'm just at the final I'm flattening. Okay. You can have multiple times the convolution layer to get the features better, and then finally a flatten. So that is given to the neural network. So the neural network is densely connected neural network. The input unit here is 10. Again, the hidden layer is 10, but the output is more layer, means you just add more. You can add more layer also. If you add only one code here, you can add more layers. Okay, so that's the advantage of the neural networks. You can add more layers. Similarly, you can add more convolution layers. After that, just run this. When you run this, you have the neural network is formed, and the convolutional neural network is also formed. We are not trained with this form. Then look at the summary. So when you look at the summary, you can see the shape and size of the neural networks. Okay. So model is sequential, convolutional neural network. The input shape is 62, 62, 32. And then there's some parameters are there. Max pooling, when you're doing the max pooling, you'll get 31, 31. In the second time, when you are applying the convolutional neural network, the size is 29, 29. Again, 32 layers, 14, 14, max pooling. Again, when you are applying the convolution layer, you get 12, 12. Okay, and then it becomes 6, 6. Okay, so that's how this convolution layer reduces there. But features are there. Features, it doesn't compromise. And then I'm flattening that. Okay, so what is that value here is 1152. Okay, after flattening, I'm getting 1152. And here the dense layers 10, 10, 10, 10 is there, and some parameters also. So this is the summary of that. So when you have the summary, okay. So when you look at here, run this program, you can see. Okay. So this is 64 cross 64. That means 4000. Size is 4000 and 1 plus 2 is 577. So remember this number 577. The 577 comes is the flattened. This is the flattened value, right? 1152. Okay. 1152 plus 2 divided by 2 is 577. Remember that. That what we are doing is we are compile. Compile is the function. That is why the compile. What the use of compile is? Uh, we are using the Adam optimizer here, and then categorical cross entropy and the accuracy. So all those things that is needed for uh, the neural network. To train the neural network, we need what? Optimizer we need, and then categorical cross entropy to find out the losses, and then to find out the accuracy. So these are the metrics. So usually we'll do compile before training the neural network. Okay, we have to fix these parameters. Many optimizer are there. Most commonly used optimizer is Adam. Then history equal to network dot fit generator. So that means we are going to train the training data set. Epoch means 10 times. 10 times means 10 times the image has been, all the images has been trained for 10 times. Okay, but we don't have time for that. Okay, we have around 4000 image. And then validation. It does the validation also side by side. Okay, because you already input the metric. When you run this, it takes some time to run the program. Here you can see the loss is cross entropy given the loss and the accuracy is given. And the optimizer that we are using is Adam optimizer. So now we are training the data set. I've given only one training. If you want to give 10 times means you will have more accuracy. It is well trained. Since we don't have time, I'm just giving only one time. Let's evaluating the neural network. Just test class indexes and then predictions. We are predicting the values. Okay, we are predicting the values for the data test one, and then we are taking the prediction values. Arg max is taking the maximum values of these two. So when you predict you have two values. So from this you have the maximum values here, and then test data set passes, and then accuracy score. So already we have seen the accuracy score is around 50%. That's the thing, and then all those things. Okay. So SNS I have not used. If you're using Seaborn, then you can use. I have not used the Seaborn. Okay. So this is how we have calculated. So what is this 577 that I told before? What is 577? So that is the thing. Here I am keeping as 10. Okay. The input layer for the artificial neural network I keep as 10. Okay. Here I keep as 10. So that is the initial value I am spending. Randomly I am fixing. But what might be the correct one is the flattening value divided by 2 plus 1 will be the correct value. So if I fix 577 here, then it will work for me in a good way. Okay, the input, because that much data has been generated at the flattening side. So here from the summary we can see 1152 data. So plus, so we can use this formula 1152 plus 2 divided by 2, that gives your 577. If you keep that as an input layer, then it would be good. Okay, so again you can run and then you can test. So if you want to classify this for any image, unknown image, just copy some of the data, unknown data, and then place over it, and then you can see this is the image that I'm sending. Again I'm resizing to 64 cross 64. After that I can see the image. Okay, so it's in a 64 cross 0 free, rescaling the values in the image. So all the values is not now in the 0 to 1 range, 0.5, 0.6, 0.7. It's not that 255 and all because I'm reselling that. And then shape is not there. Shape is there, 64,6. I'm reshaping again, and then we are giving that to the tensor. Common thing. Finally, if result is 0, 0, it's saying it is a dog because my model is just 50% only. Okay, so why I have not trained with all the values is the reason is it takes more time. Okay, I cannot explain all the steps. Okay, so just go through this code. Very simple only. The main part here is this area. So this is the place we have to. This is the place we are constructing the neural network, and this is the point we are training the neural network. Beyond that, it's just a formalities. Okay, so that's all about this one. So when training here, so you can go to the training set. And 1 minute, 1 point. Train data set, batch of 8. So you can see now, here there is 4,000 image in the training data set. But when I run the program, only one time I would run. So you put 10 times, okay, it will be good result. When I run the program, it only 500 shows. What's the reason? 4,000 images are there, but we have only 500 it shows here. What is the reason? Can anyone tell me that? We come to the end. It's easy only. Why it's showing 500? It has to show 400, but it's showing 500. The reason is I am fixing the batch size for the uh, training data set is 8. So after it takes 8 images, trained, and then it takes 8 images. So it convert that into 4,000 divided by 8 is 500. So it sees as a 500. Okay. And for training the test, I'm keeping batch size as 1. That's why when I train test data, it's showing 1,000 images. Okay, exactly the same.